Ladies and gentlemen, welcome to another episode of Lab Insider. We talk to people from all around the world, different time zones, different sectors, public, private sectors. Today, I have the utmost pleasure to introduce Professor David Wood of the Ohio State University. Welcome to the show.
Thanks. I'm glad to be here.
Thank you for making the time. I know that it is... we have you in between classes, so the fact that you've made time for us is just fantastic. But we need to get right to the point. Tell us about who you are and what position you're involved in.
Right now, I'm a full professor of chemical and biomolecular engineering at Ohio State University. My research focuses on protein engineering at the most fundamental sense, but our focus is always on generating useful technologies through protein engineering. And so the most useful technology that we've generated, in my opinion, is this self-removing affinity tag, and I have a feeling we can talk about that a little bit later. But as a quick background, I did my undergrad back in the 80s and double majored in biology and chemical engineering. And after I graduated with my bachelor's degree, I worked at Amgen for a couple of years making a drug called Neupogen. And this was in the very early days of Amgen. And so that drove me to look at the biopharmaceutical industry and some of the challenges in that industry. And then I went and finished my PhD at Rensselaer Polytechnic Institute, working primarily with a molecular geneticist, studying mobile genetic elements. And that led to my research that I'm still continuing today. And so I started first teaching at Princeton for 8 years and then moved to Ohio State. I've been here for about 12 years. I've built a pretty good body of research, and recently I started a company to commercialize my research, and we've launched our first product, and we're now having revenue. So it's an exciting time seeing 20 years of research finally out on the market with people buying it, and at the same time still being a professor, which is what I really love.
You're really balancing quite a lot of responsibilities at the moment.
Yeah, it's a lot of balls in the air at any given moment, and you try not to drop any if you can. But it definitely requires a lot of prioritization and a lot of time management and a lot of very careful organization. So if you saw my email inbox, I have like 200 subfolders to help keep me on track.
You know what? Throughout, just as you were introducing yourself, I heard your email inbox. So I know...
I turned it off. It never stopped.
We do our best. And I think that's the thing. It's disconnecting sometimes and being able to, isolate yourself and being able to focus on one thing is when that inbox just keeps bleeping. The question is, are you able to sort of separate those things? Do you switch on and narrow your focus on your protein capture science? How do you manage that?
So the easiest way to manage it, or if easiest is sort of a high bar to begin with, but I have parts of my time that are devoted to being a professor, parts of my time that are devoted to the company. And then the being a professor part gets subdivided into my classes and my undergrads in teaching, my research lab, and then the service to the department and the university. And so I try to compartmentalize things by times of the day. The biggest mistake that I make is I leave my email on and I sort of watch these messages come in, and there's a temptation to immediately put out fires as they appear. And then you find that you're constantly putting out fires, and the things that are critically important just never get done because the trivia gets in the way. And that's one of the hardest things I think for a lot of people to overcome, is this sort of keeping your eye on the long game and realizing that you can put out a lot of little fires all at once when you get home at night, instead of when you're trying to focus on, a manuscript or getting ready for class.
It's essentially like opening Pandora's box. Once you open that email, or even worse, a Teams message or something with a red receipt, that's when you feel that obligation. You have to get back to that person, that client, your colleague. But actually, when it comes to, this is a management skill, and I think we can segue into one of our talking points that we've discussed before, and that is PhD students. They need to juggle this sort of thing. You've mentioned to me that there is obviously the inherent knowledge that they possess, but that's not enough when you want to enter the industry. You mentioned management skills.
Yeah, so one of the things that recruiters keep coming to me and asking for is they want leaders. They can find people with good technical skills, but the leadership skills are pretty tough. And a lot of leadership, other than having a vision, a lot of leadership is just being able to manage your time extremely well and manage people extremely well and manage their time well. And so with my students, what I do is I assign them small groups of undergrads, and I explain to them and coach the graduate students that if you enter a company or even a professor, you're going to have to manage people. That's all there is. And you're going to have to trust those people and believe that what they're doing is worthwhile and accurate and reproducible. And that's often a training issue. And so what I tell my students, if they can train people to a point where they trust them and can then delegate things to them, they can then become much, much more effective. And so in some sense, I'm doing that myself by trying to delegate projects to them, and then they delegate pieces of those projects to their undergrads. And if everything works well, which I have to admit I wish was more common, but it does happen occasionally that I have graduate students who get very good at managing undergraduates. And the undergraduates are productive and happy, and the PhD students are much more productive than they could be if they were alone. And then they deliver data to me, and I can help them get that ready to publish or leverage it into, a good job interview or their larger long-term goals. But that's something that a lot of the PhD students, I'd say about half of them come in with a pretty good idea of how to manage time. And about half of them really need to be coached on how to multitask and sort of always have something going. So one of the things that I tell them when I was a PhD student, if I'd have 3 projects going on, I'd take 3 pieces of paper and in very bulleted points write down what I had to do for each one of those projects. And it would take about a half hour in the morning. Then I'd tape each one of those pieces of paper over my desk, and I'd pick one to start with. You line out the first one. When you're done and it's incubating or it's sitting in the refrigerator and you have to wait for the next step, you look at the other 2 pieces of paper and ask yourself, okay, what can I do right now? And then you pick one of those and you keep that up the whole day. You realize, first of all, time passes extremely quickly because you never sit down and you never stop, but you're incredibly productive. And so I try to explain that to my students. And for some of them, it's great. You see them in the lab constantly busy. Others, they want to finish a step and then wait overnight to start the next step, even when that's unnecessary.
The mañana attitude.
Yeah, yeah, and wait for data to come back. So they'll send something for sequencing, and I said, well, you could start doing a protein expression now. By the time you get the sequence back, you'd already know if it was working. And they're like, no, I want to wait. I'm like, well, you're going to lose 3 days waiting.
Do you think that's because of a lack of industry experience, or is that just some people just naturally need that extra motivation?
I feel like part of it is a lack of experience, but part of it is sort of they haven't transitioned from sort of thinking like an undergrad, where you do a homework assignment and then you don't worry about that class until the next one is due, versus being under pressure where you have to finish everything you have on your plate as quickly as possible. And so when you think of how an undergraduate course is, it's very structured. It goes in weekly cycles.
Right.
Weekly, and then every so often you have an exam. But that's not how research is. Research is you do everything as fast as you can. And I think a lot of students have trouble making that transition. They don't understand that this isn't weekly now. It's every minute of every day you should be on.
So, there have been interruptions in recent years. Obviously, a lack of physical access to research facilities and labs. You mentioned that during the course of the pandemic, people were limited to. There was one person a day was able to access the facilities, and
that was strictly for basic maintenance to keep the equipment from breaking. So they were filling up liquid nitrogen storage tanks. They were only allowed to be in the lab for 30 minutes, and it was strictly enforced. And so what we found when we came back was, cell lines that had died, reagents that had expired. And then we sort of got into the 1-2 punch of coming in and trying to start up. If you see a reagent that's expired, this is an academic lab, we have very limited funding. Go ahead and try to use it. And then a week later or 2 weeks later, or sometimes 6 weeks later, you realize you should have just bought new, because now you've wasted 3 weeks finding out that expiration date really meant something. And so I was always very jealous of industry because they can just go buy more. But in academia, you have to charge the grant. In the defense of the system, there were extra funds made available to help professors deal with this kind of stuff. But I didn't avail myself to them probably as much as I should have, partly because I was so busy with other things.
Well, it's still, it's one thing to take advantage of the funding, but you still retained that mentality that is to conserve as much as resources as possible and really it curtail any wasteful spending.
Well, in academia, and I can only speak for myself, getting grant funding is very, very hard. You put your entire soul into a proposal, and then you find out the hit rate on that grant program is 7% or 8%. It's better now, but it used to be, the way I'd explain it to my students is writing a proposal is like having a take-home exam that takes you 2 weeks to write. It's pass-fail, and a 92 is a fail. And so, and it's very disheartening. So when you finally get that grant, it's like winning the lottery. You just feel like you're on top of the world, but you're very greedy about that money. You do not want to spend it on anything frivolous. And so, and like I said, I can only speak for myself. I'm sure there's plenty of professors out there who have no trouble getting funding, whereas others may have given up. I'm still in there trying to get as much as I can. But the result is you very jealously guard the money. So you don't spend it on anything unless you feel like it's absolutely necessary.
You need to have that confidence and conviction.
Yeah, and that it's something that you really need. So my students and I negotiate a lot, and we are always looking for the cheapest place to buy test tubes. Of course, quality is important. We have found vendors that sell things that fall apart as soon as you try to use them, but those are rare. But we spend a lot of time trying to figure that out. And then my students become very good at negotiating and finding things and being very, very resourceful and sort of keeping things going. And it's been good. But I mean, we have students who know how to fix pretty complicated pieces of equipment on their own because we just don't have the money to call somebody in. So they become very technically adept as well. That
being said, raising using university facilities, there is somewhat a win-win situation in which, should you wish to pursue a private sector project, it is possible to make use of university resources only if, under certain conditions. Is that correct?
Yeah. So I have several industry-funded projects that I've had over the last few years. I have 2 that are active now. The way it works at Ohio State is what they call it a research contract. And so the company will ask me to do something ideally pretty interesting for them, not just run simple assays, but actually do some interesting development work. And it's usually something they can't easily do themselves because they don't have the expertise or they don't have the bandwidth. And so they will approach me. We'll create a contract with the university, and then 2 criteria are sort of unique to those. One is they also have to pay indirect costs to the university. So about 1/3 of the grant just goes straight to the university. Mm-hmm. The other 2/3 come to the professor. And most of that goes to supporting a student. So by the time you're finished supporting the student and paying off the university, there's usually about 15% of the grant left for all of the actual research itself. The second thing has to do with intellectual property and publishing. So most universities, and I'm going to say all, but there may be an exception, will not sign any research grant that does not allow them to publish the research. Mm-hmm. So the university's job number one is to get PhD students out the door. They need to publish in order to be ready for their career. So if a company approaches us, they need to recognize that whatever we do for them eventually has to be publishable.
That cannot leave the building, as you mentioned.
Yeah, it has to be publishable. And then the second piece always has to do with intellectual property. And that's where things can get very complicated, and different universities have different models for handling that. So let's say they give me a project that's likely to lead to a lucrative patent. The question is, what happens with that patent? At my university, if it's not a life sciences project, they have what they call the technology access fee, where you're sort of betting on the patent. So if you pay 25% additional up front, you can have the patent assigned to you as the sponsor if you're an industry sponsor. If you pay 10%, the university keeps the patent as the assignee, but you get an exclusive license. And then if you don't pay anything up front, the university keeps the patent and you have to negotiate a license. And they call it the technology access fee. If it's in life sciences, then that's off. The university keeps the patent and they can talk about other models for accessing the patent. Mm-hmm. But generally speaking, the university wants to keep the assignment of the patent. And there's a lot of reasons for that, legal reasons. Universities, as responsible stewards of federal money and state money and all of the university resources, they need to make sure that any intellectual property that they create is actually commercialized and becomes a benefit to society. So that's the philosophy. And so the fear is that a company may see a valuable technology that they can use to block other companies. And so they do what they call a capture and kill, where they get an exclusive license to that patent, then block other people out, but then never actually commercialize the intellectual property in the patent. And so the patent becomes worthless other than its blocking power. And that's something that universities are not supposed to do ever.
How far can something like this go?
It can go as long as they can keep it going. The process, they actually call it evergreening. So you keep your patents going. The way I explain it to people is if you have a drug that's making $10 billion a year, it's making about $300 million a day. And so if you can stop another company, delay them by a month or 2 months or a year, you can make more money than your lawyers will ever be able to eat. And so as a result, you have, what I see is almost frivolous lawsuits. But as long as they can keep those lawsuits going and delay the other companies. Now, the laws have changed a little bit so that the other companies can come in, but there's a lot of risk involved because if they end up losing their case, they have to pay damages. So there's a lot of patent dancing and there's a lot of sort of legal and technical terms. But the idea is that if you have a $10 billion drug, you really don't want to lose those revenues. And so there are some companies that shall remain nameless who have innovator drugs, and they have a whole part of their webpage saying, don't take the biosimilar, they're terrible, they're not as good, you need to use our original. But that very same company has biosimilars that they're making. So there's another part of their webpage saying, wow, biosimilars are so much better than the innovators because they're made under new technology. And you see this weird schizophrenia, and you realize it's all driven by these incredible revenues that they can generate.
Well, let's go into one other subject that is quite close to everyone's heart, no matter what sector we work in, and that is the subject of employee well-being. Because there's one thing that we haven't yet shed light on here in Lab Insider, and that is the lab life. The idea of the work-life balance, working to live and living to work. Take us through that, please.
I have this conversation with mostly undergrads, because by the time they're a PhD student, they've kind of made the decision that they're going to live to work. But the argument is, there's sort of two ends of a spectrum. One is people who work to live, who they go to work, they get a paycheck, and then they live their life. They buy a boat, they have a garden, they go on vacation, they go to Disneyland.
And that's it.
And then there's the other people who wake up in the morning thinking about their job, spend the whole day, like me, putting out fires, frantically trying to catch up on things, go to bed at night thinking about work. And the paycheck, it goes into a bank and puts a roof over your head, but otherwise you don't really think about it very much. And those are people who live to work. And there's a spectrum in between them. What I explain to undergrads is if you're a work to live type of person where you want a paycheck and then you want to have a family and a personal life, don't get a PhD. It's not worth it because you'll get a good paycheck. And what I explain is in the 5 years or 7 years that it's going to take you to get a PhD, the person who went straight into industry with a bachelor's degree now has a 7-year or 5-year head start on you in terms of building revenue, paying off their house, getting a. You're coming in from scratch, and they've also had 5 years of raises. So you may come in at a higher pay than them, and you may have a higher terminal pay than them, but you're now catching up with 5 years of them having actual full salary, and it could take you 10 or 20 years to catch up with them. So unless you really want to live to work and manage people and be calling the shots and do research, it's absolutely not worth it to get a PhD. And that's what I tell my students. So by the time they come in as a PhD, they've kind of implicitly made the decision that they're going to live to work. They're going to really drive this research. They're going to become a leader in a company. They're going to make a lot of money eventually, ideally, if they make it into management. But they really love the science. And the goal with the work-life balance is, the old saying, if you love what you do, you never work a day in your life. Yes. And so the idea is if you really love the science and you get up in the morning and you're like, I need to know what this experiment's going to show me today. You live to work, but at the same time, you love what you do. And that's how I survived being a professor. I mean, I wake up thinking of all the stuff that I didn't do last night that I should have. But I love students. I love being in front of a classroom. I love being able to help people sort of find their way in life. And that gives me such a good feeling about everything else that I can handle my 200 email boxes and that constant beeping that goes off all day of different emergencies that I have to deal with. And so you try to find that balance. There's a balance in terms of time, and that's, I think, how a lot of people think about it. But I think the way people should think about it is a balance in terms of quality of life. So if you're killing yourself doing something you hate, it doesn't matter if you're doing it 10 hours a week or 100 hours a week. You still have no fulfillment. You have no growth. You have no joy or self-realization, right? On the other hand, if you're killing yourself 100 hours a week, but you really, really feel like it's important and you're making a difference and you're really reaching your full potential, then that's a good work-life balance as well. As long as you're single. Once you have a family, I have a 6-year-old daughter, but I'm also very fulfilled by spending time with her. So she becomes part of that mess, and I spend a lot of time with her. And sacrifices are made on the work side in that case, but.
Professor, I must agree with you. Your email inbox, the sounds did not seem to bother you quite a bit. You do seem to be quite involved in that. I feel that aside from this, we've really reached a perfect ending to our segment.
Yeah. Well. Hopefully, yes. And hopefully this will help people kind of think about their own jobs. My argument with the email is that a lot of things, if you can't get to them, they eventually stop being important. And I have what I call the email permafrost, which is the messages in my inbox that go back. I think the oldest one is 8 years old now, of things that I really felt like I needed to respond to an email and I just never got around to it. And I go back and I look at those emails today and I wonder if that guy still wants that manuscript after 8 years. And so it's dangerous because you feel guilty for all of the people that you blew off. But at the same time, you realize, okay, I can probably delete a few more emails today. But my email inbox typically has between 100 and 150 messages at any given time that need to be answered. And I'd say about 80 of those are what I call the permafrost, which is emails that are probably no longer relevant, but I don't have the heart to delete yet.
So we're looking at about 60%. Is that advice you'd pass on to someone who is entering sort of the laboratory, the research environment? That what can they come to expect? That a majority of the messages and correspondence that they will get will eventually be one of those. This doesn't matter when I think back to it.
So each professor has to kind of decide how attentive they're going to be to their email. I tend to be very attentive. So that 60% built up over 8 years, those 60 messages. I hear from students all the time who come in and say, I emailed this professor, I never got a response. And I've emailed professors where I don't get a response. And I feel like those professors are maybe a little bit more relaxed about blowing off emails than I am. And of course, all professors show up at meetings and they realize that half of their colleagues are not there because they had better things to do. And so each person has to kind of prioritize what they're going to do for the department, what they're going to do for themselves, what they're going to do for their research group. And each person has to find their own balance. And I can tell you, I know a couple of Nobel laureates pretty well, and their balance of research versus email is very different from mine. So if you email them, good luck. But if you email me, I'll probably respond within a day or so.
That was Professor David Wood of The Ohio State University. Join us for another episode of Lab Insider for innovations from across the entire laboratory sector.